This is episode 1 in a 10-part series I'm calling 10 Things JavaScript Developers Should Know But Probably Don't. In this series, I'm going to cover some of the most fundamental and important parts of JavaScript that most of us, even those JavaScript experts among us, don't really know that well and don't touch on that often. Today, for episode 1, we're going to explore the idea of inheritance specifically in JavaScript, which is a little different and a little confusing. So let me fix that for you. Episode 1, inheritance. Let's go. Inheritance, not this kind, is mainly used to reduce code duplication, meaning you don't have to write the same code over and over again. It's typically associated with classes for most people and in most other languages. So if you're coming to JavaScript from another language, you probably are familiar with the idea of inheritance using classes. In JavaScript, it can be done with or without classes, but regardless, I'm going to show it to you with classes first because that's just a really easy way to demonstrate the concept of inheritance. Then we'll look under the hood with just pure objects, okay? Sounds good. So let me shrink. All right, so let's say we have two objects. Let's say I have a me object equals a const is just a pure object that has a function talk, and that returns a string called talking, right? Me.talk. Excellent. Let's say we have another object called you. You equals another object with a talk functions. Very similar concept, right? We're both humans, we're both people, and we can both talk. You.talk does the same thing, talking, right? So immediately we have two problems. Problem number one is what I call code duplication, meaning we had to write this function twice, obviously, right? Once down here for you, once up here for me. Well, what's wrong with that? That's just one line, I'll do it twice. Well, there's a couple of problems there. Number one, every time you're repeating a step, as a programmer, there's probably better ways to do it. So in real life, most functions aren't just one line return of a string, right? Logic is usually more complicated than that. So let's say instead of one line, the talk function had 10 lines, right? So instead of 2, you would end up with 20 lines. But even then, it's kind of reasonable to ask, so what? I just copied it one time and I'm done with it. Well, the problem with that is, what if we have a me object and we have a you object and we have a he object and a she object and a they object? We have to copy this function, this functionality for every single one of us, right? So you end up with a lot of duplication. In real life projects, that's a big no-no. Bad idea. Second problem is if there's something wrong with this function and now we have to go fix it. Let's say we have a bug and we have to update the function. We don't just have to do it in one place. We have to do it in every place, right? So if the logic that I wrote for this talk function in the beginning and then I copied it 4, 5, 6 times, if there's something wrong with that, now I have to change it in multiple places. Bad system, not a good idea. So one way to fix this is using inheritance. So first I want to show you how we do it with classes. So we can create a class of person, right? Class person that has a function on it that's very similar, same idea, the talk function. And then I can create objects, a me object and you object, using this class template. So const me equals new person. And then we can have another one, const you equals new person. Me.talk does that, you.talk does that. So great, this is beautiful. We solved the original problem of duplication. I just wrote the function one time and I'm using it as many times as I want, right? So this is great. This also means that I can create this, I can have 10 more of these objects. The function is still in one place and really wrote one time. Excuse me 1 second, thirsty over here. So that's problem number one. What is problem number two with updating the function So how can I fix this if there was a problem? So do I do me.talk equals some other function and fix it? Well, we can't really do that. I mean, we could, but let's take a look at the object first. Let me clear here. What is me? Me is of type person. There's no talk on it. So if I do me.talk, what are we, when we're trying to read it and it says talking, where's that coming from? Well, if we take another look at me, even though it's of type person, and even though we don't have a talk function on it, you can see we have actually something called a proto. Right? There's a property here called proto. If I open the proto, there's some interesting stuff here. There's the constructor, and then there is the talk function that we wrote, right? And it's got all this stuff, arguments and blah, blah, blah. The point is, me directly doesn't have the talk function on it. And I can show you if I add me that age equals 12, right? Let's take a look at me again. Age shows up, but the talk doesn't show up. Well, that's because talk is on our prototype, meaning on our class that we inherit from. Me is an instance of person. So if I want to update that thing, I have to actually tap into the proto. So keep that in mind for a second. Let's also take a look at person. If you console log person, the class, it doesn't really show me much. It just shows me the class. But if I do person.prototype, slightly different than the proto, but we'll get to that in the next video. I see some familiar stuff. It's sort of this similar concept of the proto that was on the me object. Actually, they look very, very similar. Let's see if they're the same thing. Person.prototype triple equals me.proto. True. So they're the same thing, which is great, which means the me.proto.talk is actually the talk function that's on the prototype of person. So if I want to fix our second problem, which was fixing the original function that I wrote because it had a bug in it, all I have to do is say person.prototype.talk equals some other function. And this one returns a new and improved talking. So if I do that, now let's clear me.talk has the new stuff, and you.talk also has the new stuff. So we solved both of our problems. This is really nice. So that's a class-based inheritance, kind of, not really. I mean, we're still dealing with prototypes, but that's, in essence, creating a template where you can inherit from. So let's put classes aside for a second and talk about the pure objects. And that will explain the prototype thing a little bit better. So you might have heard in JavaScript that inheritance is done through objects and specifically prototypes. And that's what we call prototypal inheritance, right? In fact, the example I just showed you uses objects and functions and prototypes underneath, even though we use the keyword class. That's something that we call syntactic sugar, meaning it's not really classes, it's just a really easy way to read and write it, because the syntax of object and prototypes and inheritance in JavaScript is a little weird and annoying. So the friendly folks at the JavaScript headquarters were nice enough to give us the beautiful class syntax in ES6. Thank you very much, guys. Thank you, wherever you are. There is no JavaScript headquarters. I do think it's important to understand how inheritance is done under the hood with objects, though. So let's go back to the browser and I'll show you. Let me shrink me again. When you create a person class, what JavaScript is doing underneath for you is creating a function called person, and it does what it needs to do. And in fact, the one that we created doesn't really do much. But then what JavaScript is doing is it's going directly on the person.prototype, and it's adding that function for us. So when I do when I create the talk function, person.prototype.talk becomes the function that I declare. So if it returns talking, right? If I do that, then I'll do const me equals new person. Essentially, it gives me the same result. Me.talk equals talking, right? And let's take a look at talk. Me, and we'll take a look inside, and it's exactly the same idea, right? I don't have a talk on the me object, but I do have a talk on its prototype. Now, another way you could do this, and this is an important thing to remember, is that you can also have by the way, this is called a constructor function, right? So you can have another constructor function, similar idea, but instead of adding the talk method on its prototype, I can say this.talk equals function and whatever it is, whatever the logic is that I want, return talking. Right, so if I do this and say const me equals new person, me.talk still works. However, there is a difference here. If I console.log me, the talk is now directly on the person. So what does this mean and why is this important, right? If I can add the function directly on the this object, then why do I need prototypes then? Well, for one thing, when you add anything, including a function to the this object inside your constructor, it won't be regarded as a method. It is regarded as a property, just like a string or a number or a Boolean. And more importantly, the function itself that you wrote, however many lines you have, actually gets copied onto that instance, onto that child object. Again, that's one of its properties. Whereas if you add it to the prototype, it's considered to be a method. And what's wrong with having it be a property? Again, well, technically you can still access it the same way as you saw by calling me.talk. But like I said, it gets copied to each and every one of those instances, which means that if you need to modify that function later, you're gonna have to change it in every one of the instances. So it sort of defeats the purpose of inheritance. I mean, it's not inheritance anymore. The same way updating a property on an object isn't going to cascade to all of its other instances of that object. Let's take a look at another example with properties, so this will hopefully make a little more sense. So let's say I have a function person, and this guy has this.age equals 12. Then I'll create an instance of it, const me equals new person, right? What is me? Me already has an age on it, right? So if I say person.age equals 40, me still has the age of 12. So obviously me.age equals 12. So what happened here? Person.age, I thought I just changed it. Well, that's the thing. If let me recreate that actually one more time. Function person, and it has an age of 12. And if I create a constant me equals new person, right? Me.age is 12, but person.age is actually undefined. So it's not even on my class. It's not even on my prototype.h, right? It's just a property of the object, which is an instance of that function person. So it only belongs to the me. So it gets copied and gets added to the me object. Yeah, so it's pretty common to add all the properties to the this object inside the constructor, but then add all the methods to the prototype of its parent. It also gives you a really clear separation of properties, things I have, versus behavior, method, things I do. This is by convention very common. One other really important feature of inheritance is the idea of extending behavior. So let's say you want to borrow your friend's jacket, but you want to use your own pocket square. You should be able to do that. And inheritance allows you to do that with code. Let me show you what I mean. So let's say you have a class person, just like before. I'm going to write this a lot today. And it has a talk function, right? Every person can talk and return talking, just like before. And me is going to be a new person, right? Simple stuff. We've done this already today a bunch of times. Me.talk works. Now let's say I have another class, superhuman, super person, that extends person. Ooh, what's this? This is interesting. Okay, and this guy does have another function called fly. Whoopsie daisy. Which returns flying to the moon. Right? So you, my friend, are const u equals new superhuman, which means u dot fly works. U dot talk also works, which is amazing because the superhuman does not have talk on it, but it can extend person, which does have a talk on it. However, me.fly is undefined, right? Because I am an instance of the person class, which does not have fly on it, and it does not extend a class that does. All right, so that's another really important feature of inheritance. Okay, so let's go back to the way we created our objects for inheritance, right? We use the new keyword every time, whether it was class or a function. There are two other ways you can create objects that inherit from one another. We already looked at the class and the function. What about a pure object, right? Let's say I have a const person equals just a brand new object, and it has the same talk function on it, and it returns talking, right? How can I create a me object that is an instance of this person and can use the talk function? Well, you can say object.create and pass in the object that you want to be sort of the parent of the me. Me.talk now is inherited, so I can create objects that way as well. And there's one more way you can use just pure objects to create this stuff as a template for inheritance. Again, same idea. This is the last time, hopefully, I'm writing this for the day. This is the millionth time. I can say const me equals just a pure object. Obviously, me.talk is not going to exist because me is just a pure object. It has no relationship with person. But then I can say object.set prototype of me to be person. So the first parameter is the instance, and the second parameter is where you want to inherit from. Now I can say me.talk, and that's there, right? So set prototype of will set the prototype of an instance of an object to another object. So these are all essentially creating the same pattern over and over again. These are just a few different ways that you can do it. So where would you use inheritance? If you're creating objects that have shared behavior, if you have components that have shared functionality, say you have a class that creates UI elements and adds them to the DOM and adds, events and event handlers, click handlers to them. Every single time you do that stuff, you're writing a lot of boilerplate code, right? If you don't want to repeat all those steps, you can create a class, a component class, and just call those methods, and the class will take care of it for you. Excuse me. Most of your beloved frameworks like React and Vue and Angular and all that stuff, they use inheritance all over the place. Take a look at this page, components and props on React docs. When you create a React component using classes, right, you are extending the React component object using extends. It's the same thing. And that's just an object that the amazing people at React have already created for us. If you're working with web components, if you know what those are, you are extending HTML element. And so inheritance is used all the time, all over the place in modern applications, even though you may not be aware of it. Okay, so obviously there is a lot more to cover when it comes to inheritance, but hopefully you get the gist of it, right? So go try it. And if you're confused about the whole prototype thing and prototype versus proto__, and which one's which, don't worry about it. I dedicated the entire next video to the difference between those two. And that's episode 2. If you want to see all 10 videos, make sure you subscribe so you're notified when I release them. Yeah, let's move on to prototypes, and I'll see you there, my beautiful babies.